Good morning everyone. I am Annapurna, working as an assistant professor in the department of ECE at Institute of Aeronautical Engineering. Today we will going to study about different types of oscilloscopes we have. In this, first one is sampling oscilloscope. This sampling oscilloscope is used at high frequency. The main purpose of the sampling oscilloscope is it generates the output only when the sampling gate is opened. That is the advantage of sampling oscilloscope. So the main blocks present in the sampling oscilloscope are ramp generator, voltage comparator, staircase generator, attenuator, vertical amplifier and sampling gate. These are the main blocks present in the sampling oscilloscope. So coming to the operation, whenever we apply the input signal is given to this sampling gate. So this sampling gate, the input signal is sampled here and the sampled signal is waited till the sampling pulse is applied through voltage comparator. Whenever the sampling pulse is applied, then only the sampling gate is opened. Then that input signal is given to the vertical amplifier. Through this vertical amplifier, that is given to vertical deflection plates. So even though the input signal is sampled, that need to wait till the sampling pulse is applied. Whenever the sampling pulse is applied to the sampling gate, it opens the gate. Then the sample signal is given to vertical amplifier. Through this vertical amplifier, the input signal is given to the vertical deflection plates. Similar to the normal oscilloscopes, in this sampling oscilloscope also we have one set of vertical deflection plates and one set of horizontal deflection plates. Finally, we have one set of vertical and one set of horizontal deflection plates. So initially we are applying the input signal is sampled here. Meanwhile, whenever we apply the triggering pulse, the oscillator will generate the pulse signals. Then if you apply those pulse signal, then the ramp generator generates a sawtooth waveform or a ramp signal. With the help, the same ramp signal is applied as the input to the voltage comparator. As we know that comparator will compare given two input signals and according to that it generates the output. So from this ramp generator we are generating a ramp signal or sawtooth signal. One of the input for the voltage comparator is the ramp signal and another input for this voltage comparator is the staircase generator. So from the horizontal, from this attenuator section, we are applying the one of the input as the ramp signal and another input for the ramp signal is the output coming from the staircase generator. This staircase generator generates the output with each stage consists of certain amplitude, like that staircase generator generates the output. So at each stage the voltage comparator will compare the ramp signal coming from the ramp generator with the staircase generator. Whenever both the amplitudes are same, then the staircase generator move to the next stage. If both the amplitudes are same, then voltage comparator sends the sampling pulse. Whenever voltage comparator sends the sampling pulse, then the sampled signal present in the sampling gate will be amplified and that is given to vertical amplifier. Meanwhile, the input signal is present in the sampling gate has certain delay. At the same time, the output present in the staircase generator is given as the input to horizontal signal or horizontal deflection plate. So, sampling oscilloscope is nothing but it is used at high frequencies. At the same time, the sampled signal is transmitted to the vertical deflection plates whenever sampling gate is opened. And when the sampling gate is opened means that depends upon the sampling pulse. And the sampling pulse is generated only when the ramp signal and the staircase generator output, both the amplitudes are same, then only the voltage comparator sends a sampling pulse. With the help of sampling pulse, the sampling gate is opened so that the input signal, whichever sample, that is given to vertical amplifier. This is an operation present in sampling oscilloscope. Once again, observe the sampling oscilloscope. Similar to the normal oscilloscope, in the sampling oscilloscope also, we have one set of vertical and horizontal deflection plates. At the same time, for the vertical deflection plates, there exists certain amount of delay. Due to this delay, both vertical and horizontal deflection plates produce the output at the same time. And coming to the operation, initially the input signal is given to the sampling gate. Across the gates, the input signal is sampled. Meanwhile, that if you apply the triggering input, according to that the oscillator generates the pulse signal. So with this pulse signal, if you apply to a ramp generator, it generates a sawtooth waveform. So this sawtooth waveform is given as the one of the input to the voltage comparator, and another input to this voltage comparator is the output coming from the staircase generator. This voltage comparator will compare these two signals. When both the amplitudes are same, then voltage comparator sends a sampling pulse. According to that sampling pulse, the gate is opened and the sampled signal is given to vertical amplifier. This vertical amplifier will give the input to vertical deflection plates. At the same time, the output coming from the staircase generator is given to horizontal signal. So, without any distortion, the vertical and horizontal deflection plates produces the output on the CRT screen. Next one is traveling oscilloscopes. These traveling oscilloscopes are also used at high frequency. The main difference between normal oscilloscope and the traveling oscilloscope is it consists of a series of vertical deflection plates. A normal oscilloscope consists of only one set of vertical deflection plates, whereas traveling oscilloscope consists of series of vertical deflection plates. That is, throughout the CRT or throughout the cathode ray tube, the vertical deflection plates are present. So, it is called as traveling wave CROs. Why? What is the need of this series of vertical deflection plates? Means as we go for high frequency, as it is operated at very high frequency, the electron beam, whichever coming from the electron gun, does not have sufficient time to meet the vertical or horizontal deflection plates. As it does not have to meet the time, means as the frequency is very high, the electron beam does not have sufficient time to meet vertical deflection plates. So that throughout the CRT, if we place the series of vertical deflection plates, according to the frequency of operation, the electron beam will meet the particular vertical deflection plate, and parallelly, the horizontal deflection plate has the input from horizontal amplifier, and finally it produces the output on CRT screen. And another type of oscilloscope is the sampling storage oscilloscope. This is called as storage oscilloscope. Storage oscilloscope. Till now we have discussed about different types of oscilloscope, but those oscilloscopes does not have storage capacity. So whenever we apply the input, it produces the output. After that, when we change the input section, according to that, there is a change in the output and it won't store the previous data. But coming to the digital storage oscilloscope, as the name indicates that it can store the data, depends upon our requirement, and whenever we want to retrieve the data, we can retrieve it from the screen. So, coming to the digital storage oscilloscope, the main blocks are amplifier, digitizer, memory unit, analyzer circuit, waveform reconstruction, horizontal amplifier, time-based generator, and trigger and clock circuit. The same storage oscilloscope can also be rewritten or read like this. Both are same. This is also digital storage oscilloscope. Only the way of representation is different, but both the diagrams include digital storage oscilloscope only. So, whenever we are applying the input, similar to the normal oscilloscope, this digital storage oscilloscope also consists of one set of vertical and one set of horizontal deflection plates. But along along with this vertical and horizontal deflection plates, there exists one device that is called as memory unit. With the help of that memory unit, we can read the data from it, or we can write by using this memory or control logic. We can read the data from the device, or we can write the data into the device. That is the advantage of the control logic and memory device we are using here. So coming to the operation, initially we are applying the input to the preamplifier and attenuator section. The main advantage of using preamplifier and attenuator is, if the input signal has any noise, that noise can be removed with the help of attenuator, or unwanted signals are removed by using this attenuator. Only the required amount of input signal will be transmitted, and by using preamplifier, we can strengthen the input signal. Then the input signal is given to sample and hold circuit. In this sample and hold circuit, we can sample the input signal, that is, we can take the input and the input levels are equalized. For example, if you take any analog signal, if it is an analog signal, the input signal is continuously varied with respect to time t. But coming to the digital signal, it has only two levels, either ones or zeros. So we are representing the data in terms of ones and the zeros, but whenever we want to store the analog signal in a memory unit, instead of transmitting the input signal in a continuous manner, we are taking the samples of input signal. In the sample of input signal means, the input signal is sampled like this. We take the samples of input signal. After that, amplitude levels are equalized. We have equalized amplitude levels, so that we can say that at this instant, for example, if this is 0, 0 0.2, 0 0.4, 6, 0 0.4, and if you have any sample signal here, point, like that, we are taking the input signal and the input signal is sampled and the amplitude levels are equalized like that. Then that input data is converted, and this analog information is converted into digital data. What is the need of converting analog input into digital means, whenever we store the data in digital format, then we can store it in. Whenever we want to store the data in a memory unit, we need to convert analog information into digital way. So that we are using analog to digital converter. With the help of analog to digital converter, we can convert analog information into digital data, and the digital data is stored in the memory unit. Meanwhile, the same input signal which is given to the vertical amplifier, that is given to this triggering circuit, whenever the input signal is given to the triggering circuit, it generates the triggering pulse. At the same time, the input is given to control logic, and based upon our requirement, we can read or we can write the data into a particular location, memory location, and that is given to memory unit. So again, across the horizontal amplifier section, the digital data is again converted into analog data, and that is given to horizontal amplifier. Why we are converting again the digital data into the analog format means, in our CRT screen, if you want to represent the output in our CRT screen, we have to represent it in analog format only. The digital data does not support in CRT, so that we are converting our digital data into analog, and that is given to horizontal amplifier. Now horizontal amplifier will give the input to horizontal deflection plates, and meanwhile from this memory unit, the input signal coming from the input section is again converted into analog, and that is given to vertical amplifier. Now the vertical amplifier give the input to the vertical deflection plates. Finally, the horizontal and vertical deflection plates will produce the output at the same time. In this section, whenever we apply the triggering pulse, according to the triggering pulse, it generates the ramp signal, and the ramp signal is with respect to the ramp signal, the horizontal amplifier will take the input from this control logic and the data is converted into analog format. That will be done internally in the control logic itself. So this is called as digital storage oscilloscope. In this digital storage oscilloscope, the initial input signal is sampled and then the sample data is converted into digital format. Then the digital information is stored in the memory unit. After that, whenever we want to retrieve the data present in the memory unit again that is converted into analog format and which is given to the vertical amplifier section. At the same time, same digital to analog converted data is given to horizontal amplifier section. From this vertical and horizontal amplifier section, we are giving it to the vertical and horizontal deflection plates. Once again, observe the digital storage oscilloscope. In this digital storage oscilloscope, it is not only used to represent the waveform on the CRT screen, it can also be helpful to store the data whenever we want to retrieve. We can retrieve the data. And how much time it can store the data, and that depends upon our requirement. If you want to see the data or if you want to verify the data after 1 hour or like that, we can store the data like that in memory unit, and whenever we want to retrieve, we can retrieve the data. So the main blocks present in this digital storage oscilloscope are memory unit and control logic, along with this sample and hold circuit. So we are applying initially the input signal to the preamplifier and attenuator section. In this preamplifier and attenuator, the input signal is amplified, that is strengthened. At the same time, unwanted signals are attenuated. Then the input signal is given to sample and hold circuit. At the same time, the same input signal is given to the triggering circuit. In this triggering circuit, it generates the pulse signal. According to that, the pulse signal is generated. According to that, the ramp generator generates the ramp signal, which is given to the horizontal amplifier. So this horizontal amplifier will take the input according to the ramp signal. Meanwhile, the input signal coming from the input section is given to the sample and hold circuit. In this sample and hold circuit, initially the input signal, the analog signal is sampled like this. Then it will equalize the input voltage levels, equalize the amplitude levels. Whenever it equalizes the amplitude levels of the input signal, then that input or analog signal data is converted into digital data with the help of analog to digital converter. After that, the digital data is stored in the memory unit, and whenever we want to retrieve the data, again the data present in the memory unit is again converted into analog format. That analog data is given to the vertical amplifier section. Meanwhile, the horizontal amplifier, across this horizontal amplifier section also, the digital data is again converted into analog format and that is given to horizontal amplifier. Finally, the horizontal amplifier and vertical amplifier will give the input to horizontal and vertical deflection plates, so that without any distortion or noise, it produces the output on the output screen. This is called as digital storage oscilloscope, and we can represent the digital storage oscilloscope either in this block diagram way or in this one. Both are same. In this case, instead of analog to digital converter, we are calling it as digitizer. Similarly, digital to analog converter circuit is called as analysory circuitry, and this is waveform reconstruction. To get the original signal, that is called as waveform reconstruction. And here along the horizontal amplifier section, when we apply the triggering pulse, the time-based generator generates the ramp signal. According to that ramp signal, horizontal amplifier will take the input and then that digital data is converted into analog, and that analog information is given to the horizontal deflection plates. So, Both the diagrams represent the same purpose, digital storage oscilloscope. Only the difference is in this, instead of analog to digital converter, we are calling it as digitizer. At the input section, we are using amplifier. Amplifier itself, it consists of both preamplifier and attenuator section. The preamplifier and attenuator section means it strengthens the input signal. At the same time, if there exists any noise or unwanted signal, that noise or unwanted signal is removed. So, this memory unit will store the data. Digitizer means which is used to convert analog information into digital format, and analyzer circuitry means again we are converting digital data into analog format. What is the need of converting the digital data into analog format means in our CRT we can represent the output waveform in analog format only. So we are converting digital data into analog format, and the memory unit is mainly used to store the data. Whenever we want to retrieve, we can retrieve it from the memory unit. So to store the data in the memory unit, initially we are converting our analog data into digital format, and whenever we want, we can retrieve in analog format by using digital to analog converter. These are the different types of oscilloscopes we have. In this first one is sampling oscilloscope. The sampling oscilloscope also used at high frequency, and this is operated only when the sampling gate is open, and the sampling gate is opened whenever the two inputs for the voltage comparator, that is output across the ramp generator and the output of the staircase generator, whenever both the amplitudes are same, then only this voltage comparator generates the sampling pulse. According to that, the sampling gate is opened. If the sampling gate is opened, then the sampled signal is given to the vertical amplifier, and through the vertical amplifier we will get in the output section. This traveling wave oscilloscope also used at very high frequency and ultra high frequency. As the frequency increases, the electron beam does not have sufficient time to meet the vertical deflection plates. So, throughout the CRT screen we are using, throughout the cathode ray tube, we are using this vertical deflection plates. And this digital storage oscilloscope, whether it is in the first format or in the second format, the digital storage oscilloscopes are mainly used to store the data in the digital format, and whenever we want we can retrieve it from the memory unit. Okay. These are the different types of oscilloscopes we have. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.